Yeah, good morning, ladies and gentlemen. My name is Marco Scholz from Uniper, and I would like to present our Maasvlakte project to you. Today, the plan concept and the status of the project. So first of all, I would like to give you a short overview on the core markets Uniper is working on. Obviously, it's the Netherlands in Rotterdam, and it's Germany with flagship projects in Wilhelmshaven, for example. Then also the UK with Killingholme project in the Humber Hub region, and Sweden, where we work on hydrogen projects, for example, the project AIR. To give you a project overview, in Maasvlakte, on the site, we have all the ingredients to produce large-scale hydrogen. Our ambition is to install 100 megawatt in the first phase and to extend that later to 500 megawatt. And I'll show you in this presentation how we are going to do that. So the location is really unique. We have proximity to the backbone and proximity to offshore wind power. And the concept is really to use offshore wind power, convert it into hydrogen, and then feed it into the backbone for industrial users. And of course, making use of the site infrastructure as much as possible. So the project is currently in the FEED stage. Soil investigations are done, geotech studies are finished. We have selected all the concepts and the design freeze. The plot plan is ready. Recently we finished all the safety studies like hazard, LOPA analysis, and the 3D model is almost finished. At the end, of course, one key aspect is cost estimates, which we expect in summer, and also EPC schedules and all the information we need to really further mature the project. We have selected the plug power PEM technology to produce the electrolyte or the hydrogen in the first phase of the project. And one key aspect is also to do a compliancy check with the grid operator. I will give you some insights on that during the next minutes. Here on the right-hand side, you find some images of the 3D model. One building is a 50 megawatt block, having the electrolyzer on the first floor and the power block on the ground floor to save space. So why is the location in Maasvlakte so unique? On the left-hand side, you see the existing coal-fired power station, and this blue circle here is showing the plots where we are going to build the electrolyzer facility, 500 megawatts in the first phase. So the site is perfect because next door there's a substation already from TenneT, where by 2030 more than 7 gigawatt of wind power will land. And in order to have really a good site for system integration, to not put too much energy through the grid, we can install a large-scale electrolyzer at this site. One interesting aspect is that these two power blocks you see here in the back of the picture, these are two decommissioned power plants. Each of them have produced 500 megawatts, so the grid connection is already there. The cable is still in the ground, and we will repurpose this existing grid connection from push to pull to operate at least one large-scale electrolyzer. So infrastructure for dim-in water is available, seawater cooling is available, land is available, and of course the site is in the heart of the port of Rotterdam, so an ideal location, really. A minor aspect is that we also have existing facilities already for construction. From previous projects, we all have contractor facilities on site, still maintained for long years and can be used right away, so we can implement projects quite easily. So how does the plant concept look like? It's a typical electrolyzer setup with the dim water supply, water polishing. Then we have the PEM electrolyzer, purification and compression. And then we have two options. The bulk hydrogen will be supplied to the pipeline, but we also have the option to fill it to tube trailers. This is already included in our planning. One important aspect is that the plant is also designed for dynamic operation. Yeah, so the plant will follow the wind profile to produce hydrogen. And it is also planned already from the beginning to extend from 100 to 500 megawatt. Yeah? And with this concept, it's a blueprint for other Uniper sites. For example, in Germany, the Wilhelmshaven site, they have same conditions, and we want to copy this 500 megawatt concept also there and even extend it to larger scale. So here you find two nice 3D images, how the plant will look like. On the left-hand side, it's the east view. On the right-hand side, it's the west view. So in the front of the east view, you see the utility area. It's the dim water supply, it's dim water pumps, it's cooling water, nitrogen, instrument air. And this entire utility area is sized for 500 megawatts from the beginning. Yeah? The same applies to the main pipe rack, which you see in the middle of the electrolyzer buildings. And then on the left-hand side, you see a new control building, and close to that is an existing building. Yeah? It has been a substation in the past. We will reuse it and install a new GIS there. If we have a look at the west view, so it's then from the other side of the plot, you see the purification area. It is already sized for, in some aspects, for 100 megawatt, in others for 500 already. So there's deoxo reaction, for example, the compression unit, also oxygen and hydrogen vents. Yeah? And of course, we have the main electrical equipment, everything more or less combined in this former substation. So having a look at the site from the top view, this red box shown here is the area which will be used for the 500 megawatt electrolyzer. The currently operating power block will be decommissioned one point in time, and then we can even use the blue box for another electrolyzer, so to scale it to 1 gigawatt. As mentioned before, we are very close to the substation here, where already significant wind power is landing, and the grid connection to this decommissioned power plants shown in this blue box in the middle is still there. Yeah? So we will use one of these connections to redirect that and to feed the electrolyzers. Also interesting, the green box at the top and the yellow box at the bottom, it's a cooling water system. So there's a significant seawater cooling system in place, which has been used for the two decommissioned power plants, and we can make use of that for the electrolyzers quite easily. Yeah, so the idea is to make as much use of existing infrastructure as possible, but not link it too much to the existing power station, because once it's out of operation, then we still need to operate the plant, right? Yeah, as mentioned, just to give you an impression on the electrical grid connection. So these are just two photos. You see the TenneT substation and this black building in the background is the former substation. which we maintain, and where new equipment will be installed for the electrolyzer. So it's really close. We can easily connect that cable. So one cable has a capacity to feed the 500 megawatt electrolyzer, and the second cable, of course, can be then used for the extension later even. Yeah, so it's repurposing from push to pull, and this compliancy check is initiated, it's ongoing, and then we are ready to really use this connection to feed the electrolyzer with wind power. Yeah, so this is a nice drone picture and an image how the plant can look like in the future. So, as mentioned here, you see the utility area, dim water tank, nitrogen supply, instrument air supply, the buildings with 50 megawatts electrolyzer power capacity each. And yeah, as mentioned in the first phase, we would install 100 megawatts, and then depending on the demand, we can easily scale that to 500. Because yeah, utility and purification section is already prepared to take more, and the grid connection is also then for 500 megawatts. And yeah, as mentioned, if these coal fields here are out of operation, we can more or less mirror this concept and to have a second 500 megawatt block next to this plant, and to really implement large-scale electrolyzers in Maasvlakte. Yeah. All right. I want to conclude and give you a short summary. As mentioned, we are building 100 megawatts electrolyzer in the first phase of the project, but we want to extend that to 500. The plant is designed to follow the wind profile, the wind input. We will do some pre-investments in utilities and the purification section, but there's an economy of scale effect, obviously, which we want to make use of. And yeah, we want to make use of a lot of infrastructure on site. We think it's the ideal location to build a large-scale electrolyzer. So to use the grid connection, to use the dim water and the cooling water system on site. And yeah, the project is in the FEED stage, I would say 70% completed. Electrolyzer is selected and contract signed, I would say. Thank you for your attention. Yeah.